want us to prove that the area of V plus the area of T is equal to the area of U plus the area of W. I'm going to show this in two different ways. First of all, the way the answers do it using a purely geometrical argument. What they do is draw parallel lines. So we've got a horizontal line here, and then if I carefully draw this one, this blue line is parallel to this sloping side here. So I'm just going to illustrate that on my diagram. So split large parallelogram into four smaller parallelograms. Now, the diagonal of a parallelogram will divide its area into two. And that is the absolutely crucial result in this question, because suddenly we can say that this red area here is equal to this blue area because of that fact. I don't think we need to prove that fact. I think it's enough. You could technically show that they are congruent triangles, and it would be because of side, side, side. So you could go to that level of detail, but do you know what? I might even write that in brackets. Side, 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 congruent. Yeah, okay, there we go. And now I'm just going to carefully work my way around identifying some different triangles. So here I'm going to call this U1, and this is going to equal T1. And then this will be T2, and I'll say that this is equal to W2. Then W1 will equal V1, and V2 will equal U2. I'm using U as the actual area rather than the region here, just to make life easier. You maybe could say that all of these are the areas, but you could define what they are. You could say that this, yeah. But anyway, I think it's sufficient, to be honest. So T plus V is going to equal T1 plus T2 plus V1 plus V2. Now I can use these results. U1 plus W2 plus W1 plus U2, which is equal to U1 plus U2 plus W1 plus W2. If I just rearrange it, equals U plus W. So of course there is some algebra involved, but it's mostly geometrically based. You could, even argue it without giving it symbols, I suppose, but I think this is the clearest way. Okay, nice argument. All right, I'm going to have a go at this in an alternative way. And this is how I always approach problems, just getting like half base times height involved. But I do appreciate that first method. So, right, when I did this, I decided to focus on finding U and W in terms of some, the base and so on. So this is B. Okay, now I don't know what this length is here, but maybe I say that the whole height is H. And then I could say that this is maybe Y, which means that this length is going to be H minus Y. So then W is going to equal a half base times Y. and u is equal to a half. It's like an upside down triangle, but it's still going to be half base times height. It's going to be a half base times h minus y. So u plus w is going to equal a half by plus a half bh minus a half by when I expand that bracket. So these are going to cancel, and we simply get a half base times height. The whole height's being used. Yeah, that's you might think, oh, I could have done that straight away, but I feel like I've shown it, so I'm a bit happier to do it this way. Right, V and T, little bit trickier. So let's take a little look. It's a little bit obvious, less obvious rather, to use like the base, like some of these here. So actually, what we can do is focus on this length and this length. So I'm going to say that this length is x, which means that this one will be b minus x, because remember the whole thing is b. Okay, I'm focusing up here. So now it's not obvious actually to see that the area of t is just going to be half x times h. I'm going to need to, but actually that is the case. So I'm gonna show that now. I'm going to call this one t1 and this one t2. So t1, right now I've labeled this x, is going to be a half times x times y. Okay, that's okay, isn't it? Because this is the base, and then I've got the heights here. And then t2 is going to be a half times x times h minus y. So t will equal a half xy plus a half xh minus a half xy. And again, these two cancel, and I simply get a half xh. That's a pretty cool result, really. The fact that we are just timesing this length by the height, even though it's not quite, it's not quite your traditional half base times height. It is actually a true general formula, and we've shown it by splitting it into two. And I can do exactly the same with V. So I'll call this one V1 and then V2. You can see this is more technical, but hey, I quite like it. V1 is going to be a half times B minus X, because that's now the base, times Y. And B2 is going to be a half times B minus X times H minus Y. So V is going to be a half B minus X times Y plus. Now I'm going to carefully expand this bracket because I'm going to multiply all of this by H, and then I'm going to multiply all of it by minus Y. Nothing wrong with doing that, because now it just cancels like so. And therefore, T plus V is going to be a half XH plus a half BH minus a half XH. These cancel, and I've managed to get the area of T and V, which is exactly the same as U plus W. So U plus W equals T plus V as required. Okay, two different methods, both give some insight into this problem. Quite like both. Well done.